Okay, so today I just wanted to show my data analysis for the game Wordle. We used some Python and some different CSV files that we got online from kaggle.com. And I think those are linked in the README if you want to take a look at those. But we have the possible solutions in this game and the possible guesses. And real quick, I'm just going to give an overview of the game so you kind of know what I'm talking about. So if you look over here, we see we have different inputs for words, and we're trying to guess a 5-letter word. And so if it's in yellow, it means that letter is in our the word we're looking for, but it's in the wrong position. And then if it's in S, obviously it is that letter and it's in the right spot. And so I just created a kind of Wordle solver that will allow us to input the state of our game, and then it will give us the possible solutions. So as you can see, I'm entering the letters that we know it is S-A-L, and then the letters that we know it can't be. And then this is where I'd put some yellow letters, but since we already know where they are in the word, we can leave that blank. And so now we have a list of 3 remaining possibilities for this word. So we can try snail. We'll see how that works. So that one did not work. So now we can try shawl. And it looks like that was our word that we were looking for. So this is just a little project that I've been working on, and just to kind of, I don't know, find the best way to beat this game. I'm going to switch back over to this file. So this was the first half of the project that I created, was just kind of this solver almost that lets us put in the game state and see what our possibilities that remaining are. And then the other direction I wanted to go with it was learning a little bit about letter frequency and which words would be the best words to use at a specific time. And so if I run this one, as you can see, it returns a dictionary, and it's a little bit not user-friendly, but you can see CO. And so the first letter is obviously the letter, and the second letter is the positional argument. So you can see there's 198 words that begin with the letter C. And then if we look at W4, there's 17 words that end with the letter W. And so this was just a way to look at finding a really good guess that gives us a high probability of guessing the word correctly. So if you remember from the game that I just did, I started with tears, which is a pretty good word because it has a lot of these possibilities. So if we look at it, if we find T right here, there's 149 words that start with the letter T. And then if we look at A, there's 304 words that have A as the second letter. And then we have R as the third letter. Yeah, so there's 163, and then E as the third letter right here, so 318, and then obviously S at the end, which where is S? 36. So not as many that end with S, but all the other letters really give you a lot of different word possibilities. So that was kind of the second part of this project, was trying to find the best possible words to use. And this can be reused if we input our current game state of this list. We can see the letter frequencies of what we have remaining, and so we can pick a pretty good word from there. Kind of the direction I want to continue with this project is kind of dynamically combine these two, and then output a few possibilities that would be really good words to use that where the letters are repeated a lot, and will really cut down our list the next iteration we run through of guessing our word. Other than that, I believe that's kind of the main part of this project. And like I said, it was just these CSV files that I got from Kaggle, and then just a little bit of Python, pretty common stuff, getting user input, opening the files, and then running through them and storing all the possibilities in a list and comparing them that way. But it was a really interesting project, and I hope you guys can get something out of it.